Okay. Okay, hello everyone. Any questions from the homework I've assigned? I mean, the practice problems. Anybody has any questions about them? If you do, please put them on chat. Okay. So today we're going to keep talking about what the idea that I started last time and find the general formula. So I will put up another problems very close to the problem I did last time with you. And we discuss what's really happening. So this is my second example here. Okay. So this is here the idea. We have a cookie shop. So you go to a store that sells cookies. So we have a cookie shop. And it has 5 different kind of cookies. 5 different kind of cookies. Okay, so that's our scenario. And the question is, so in how many ways, so it has a lot of cookies, so a lot of each kind, and the question is, in how many ways, many different ways, of course, can 20 cookies be chosen? Okay. So that's my problem. So you have the stores, you go there and it has, 5 different kinds, you want 20. So since you have 5 different kinds, so you have, let us say, chocolate chip cookie, you have whatever, oatmeal cookie, fudge cookie, 5 different kinds, and you want to pick 20. And of course, the chocolate chips are the same, the fudge are the same, and whatever, oatmeal are the same. So the cookies, the same kind, are all the same, and you want 20 cookies. And the question is, in how many ways can we pick them? Okay. So let us think a little bit about the scenario. I mean, I'm not going to list like I did last time. It's really not feasible, as you will realize, but let us think a little bit about it. So we have here 5 categories of cookies. So sometimes instead of using kind, I'm going to use the category. So we have 5 categories of cookies. And let us say we have chocolate chip. So chocolate chip, that's one category. Oatmeal, another category. I don't know, butter cookies, another one. What's good? Fudge cookie. And any other kind of cookie, let's say Oreos. Everybody like Oreo. 1, 2, 3, 4, 5. So these are the 5 different kind of cookies they have. Okay, and I'm gonna pick 5. So let us say I pick the following. And that's where the association is going to become. So let us say I picked 5 Oreos, and then I picked chocolate chip, like, 2 chocolate chip. Oatmeal are my favorite, so I'm going to pick 6 oatmeal. And then I'm going to pick butter are very fatty, so I won't pick a lot. So I will have 7 and 6, that's give me 13. 13 and 2, that's going to give me 15, and 5 fudge. So this is, let us say this is one selection. All right, so we're going to associate to that selection the following string. So the string 5 Oreos, we associate to them 5 stars. That's the string. And then one is, I'm separating the first category, which is Oreos. That's my first categories, from the second categories, which is the chocolate chip. So these are the 2 stars, that's the chocolate chip. And then I will have this to separate the categories. I'll have 6 of those. 1, 2, 3, 4, 5, and 6. This is my oatmeal. And then I separate them. I have the 2 fudge. And then I separate them. Sorry, I have the 2 butter. And then I separate them with my fudge. So these are the butter and these are the fudge. So that's really the correspondence I'm making. And let us note that 2 different selection correspond to different string. I mean, if I change the selection, the strings are going to be absolutely the same. So no 2 different selection have the same string. So now what's really now my problem is going to be the number of ways we can choose 20 cookies is equal to the number of ways All right, now number of ways what? Number of ways what? How we're thinking about this problem. The number of ways we can make a selection is the number of ways we can do what? So to every string, to every choice, I'm associating a string, a binary string. So binary, it means it have only 2 symbols, stars and ones. That's the binary strings. And my binary strings have how many? What's the length of my binary string? 20 for the cookies, and then the ones for the separator. So my string have 24, is of length 24. And the number of ways we can choose 20 is actually the number of ways we can put 20 stars, if you want, in a string, exactly 20 star, in a bit string of length 24. So the idea is that if I give you a string of length 24, the number of ways you can put your stars is actually the number of ways we can select our cookies. Because for every string, regardless what the string is, I can give you a selection. So let me just make this idea very clear. Suppose I give you this string. Sorry, I want 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, 15, 16, 17, 18, 19, 20, 21, 22. And I give you this string. Wow. So 1, 2, 3, 4, 5, 6, 7, 8. This is the string I have in mind. Okay, which selection I have? Which is the selections that correspond to that? This one tells me 1 Oreo. This one tells, so now I'm separating them. That's my second category. My second category was chocolate chip. 1, 2, 3, 4, 5, 6 chocolate chip. My third category, 1, 2 butter, I think. No, 2 oatmeal. And then 1, 2, 3, 4, 5, 6 butter. And finally 2, so those are the 2, represent the fudge cookies. This is the association I'm making. And every time I move those separator, if you want, then I'm gonna change my selection. Every time I move them, I change the selection. So to every selection, I have that. So the number of selection is the number of ways I can put 20 stars in 24-bit string. Or the number of ways I can put 1, 2, 3, 4 ones in a bit string of length 24. So these are exactly the same. So the number of ways we can put 20 star in a bit string of length 24. But this is equal how many ways? So I'm going to put 20. So in the number of ways, I can pick 20 position in a string of 24 position. Or it's the same thing as the number of ways. I can pick 3, 4 ones. These are the separator in a string of length 24. So now let's analyze every one of them. Let me analyze this one. We analyze it together. What does the 24 represent in the picture? And what does the 20 represent? Okay. I want you to try to think about it for a little bit and tell me what the 20 represent and what does the 24 represent?
Going back to the 2420.
20 represent what?
No, I was just curious of what is the which the one with is equal to
4.
That again? Oh, 4.
That's 4. That's the number of separator, number of ones. So the 20 represent what in the picture? Back to you. Where did I bring this 20 from? Anybody have any idea? So the 20 corresponded to what in the picture here? Those 20 represented the stars. Now the stars represented what? The stars represented the number of cookies I'm looking for. So the stars here represented the number of objects, or this is represented the number of cookies. So the 20 represent the number of cookies that I'm going to pick. What does the 24 represent? Look at the picture. Where does the 24 represent? Where did I bring 24 from? Okay, let me pick a student. You guys want me to pick one of you? Or you want to volunteer? Okay, I'll get back to you. Did anyone understand this one-to-one this selection? Did anybody understand the logic between this and that? Are you with me on this or you're not? Are you guys there? Can you hear me? So I'm going to give you another selection and you tell me what am I thinking of. Suppose somebody picked 10 Oreos cookies and they picked 6 chocolate chip and 4 oatmeal. What kind of string I am associating to this one? How does the string look like? Can anybody tell me what to draw? Somebody in mute, and please tell me what to draw in here. What shall I draw? What's the string that corresponds to this choice? Is it choosing 3? What do you mean, Peter? I have 20 oatmeal. I go pick 10 Oreos, 6 chocolate chips, and 4 oatmeal. And my question to you is, what's the shape of the string that I associate to this choice? Because we're not going to sit down and list them. We're going to associate to every selection a string. And instead of computing the selection, we're going to compute the string that we associate to. So how does the string associated to this one would look like? If you have 10 Oreos, means that's how it looks like. 4, 5, 6, 7, 8, 9, 10. So this is the Oreo category. Chocolate chips, it means 1, 2, 3, 4, 5, 6. These are the chocolate chip. The 4 oatmeal, 1, 2, 3, 4. These are the oatmeal. But this should not be enough, because if I draw this, it's not very clear what I am choosing. So the way we're going to do it is I make the bar, and here we have this fourth category, which is in our case was the butter cookie, but I don't put anything in it, no stars, because I have 0 butter cookie. And then I have this other one, which tells me that this is fudge, but there is no fudge. That's the association we are making. So to every choice here, every choice we make this string as an association. And instead of computing those, we are computing the number of string. And every time I move those ones, it means I have a new selection. So I'll give you one more scenarios with the star now, and you tell me what corresponds to it in the selection. So suppose I have that. I'm gonna pick here 1, 2, 3, 4, 5, 6, 7, 8, 10, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, suppose I have that. What's choice? What is the cookie selection that corresponds to this choice? So here I have 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. This is 7. Okay, what selection I have? What am I thinking about? And the way we're doing it by categories, 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 categories. Which selection corresponds to this picture? Back to you. How many Oreos?
There would be 0 Oreos.
0 Oreos. Because in this here, there is nothing. Okay, then how many chocolate chip?
8 chocolate chip.
8. That's what's really happening. That's the picture. How many oatmeal? That's the oatmeal category. That's what it is. Then how many butter? That's the butter category. 7. And there is nothing here. I have to reflect the fact. The string should reflect the fact. So that's butter. The string should reflect the fact I have 0 fudge cookies. So the string should reflect what I have from every single category. So there is nothing here before it, it means I have 0 Oreo. And I need those ones to tell you which category. If I don't put the ones, it's nothing. It doesn't mean anything. So the ones here play the role that to separate. That's category 1, 2, 3, 4, and 5. That's the category. And as you realize, every time I'm giving you a string like this, we can know what the selection is. So the idea is really boiling down is the number of ways I can basically change the stars, the number of ways I can locate the stars on this string. But what's the length of the string? So the stars are 20, but the length of the string is 24. Where is the 24 coming from? How many stars we have in the string? We have 20 stars. And 1, 2, 3, 4 represented what? Those are the separators between the categories. Because I have 5 categories, I don't need 1 here because there is nothing below it. So the 4 is coming from the number of categories I have, which are 5, minus 1 because I don't need the last one. So the 4 here is the number of stars and the number of separators, but I only need 4 separators. I actually don't need 5 because to separate 5 categories, I need 4 of them. 1, 2, 3, 4, 5 categories. That's really the picture. So this represent the 20, that's the 20 plus the separators, which is the number of categories minus 1. Because I have 5, I don't need 5 separators between. So the number here is 20, represent the number of cookies, and this is the number of cookies, basically, plus the number of separators. Of course, we're not going to keep calling it separators between them. But how many separators we have? We have 5 categories, so we need 4 of them to be able to separate the 5 categories. So it's going to be equal to 20 plus 4. And that's the same thing as choosing 4 out of 24, because as we've done this several times, choosing 20 out of 24 is the same thing as choosing 4 out of 24. And you can even think about it this way. The number of ways I can put the star, the 20 star, the same as the number of ways I can put those 4 ones into the string. So what's the general rule in this particular situation? What's going to be the theorem? So let us state the theorem or the fact based on what we're doing. All right, so this is the picture. So in general, suppose we have to select. Suppose we have to select. So we have to select. You're picking, you're selecting. Suppose we have to select our object from n different categories. Like in the previous one, it was 20 objects from 5 different categories, from n different category of object with repetition allowed. It means those objects are not, can repeat. The repetition allowed. It means that the objects are not necessarily distinct. The objects are not distinct. Like the cookies, there are, all the chocolate chips are the same, all the butter are the same. So the repetition allowed is given by. So suppose we have to select that. The number of ways this could be done is equal to, okay, I'm gonna give you like a minute or so to give me the formula. Think about the string. That's the only way you can understand this. Think about the string that can associate to those. I have to select all objects, but they are from n different categories. So think about the stars and the ones that we're talking about. See if this helps. And give me the formula. Anybody would like to give it a shot?
So are we saying that for the first, or for the example with the cookies, is our n, or what would we label our n and k to be? I think that's where I'm a little confused with like writing the formula.
Repeat your question. Why you're confused?
So you know how when we have like permutations and combinations, we have
Right.
n and k?
Yes.
What would our n and k be for the
It's
example
not a regular
above?
combination. This is not a regular combination.
Okay, so we're not using that?
No, because
Okay.
in the combination, repetition is not allowed. It means when we take a combination, we're assuming the object that we're selecting from are different. Are you with me?
Yeah.
Different. Here are the objects that we are selecting from. Are they different in my scenario? Or they could be the same.
I think I missed the R and N. I don't know why. I think I skipped over that. Yeah, that makes sense.
Okay, so that's the difference. That's the main difference between our scenario today and the previous scenario. In a combination, I have totally different object. There is no repetition. So I have 5 different students in my class, 5 different students. I'm picking 3 out of them. That's a combination. Are you with me?
Yeah.
Here, what's the difference here? I'm gonna select the R object, but some of those are fairly similar, very similar. So it's not really a regular combination because they are identical. So the cookies, the chocolate chip cookies I'm selecting, there are a lot of the same. They are not different chocolate chip cookies. I am not giving them numbers to make them different from one another. They are absolutely identical. That's the issue we're facing in this problem. Is it making any sense?
Yeah, I think so.
Okay, so let's go back to this formula. I want you guys to try to think about it. And I want you to try to give me the formula. Think of the stars and bars and ones. How did we think about them? So every selection here, what am I gonna do? What's in my mind? So what represent the stars in these scenarios? I use the stars to represent what? Back to you. Emily, I think Emily was talking, right? Or Rachel?
Yeah, it was me.
Emily? Okay.
The stars were, would that be the R? It was the objects, right?
The star are the object, right? So I'm picking R of them. Very good. Now, together. And the N different categories represent what?
The separators.
Exactly. How many separators we need?
It would be N-1, right?
Absolutely. Because I need to separate N categories. I need N-1 separator. I don't need all of them. So separator 1, it means I have that much from the first object. So whatever it is, these are the cookies. I took cookies because it's an easy scenario. That many from the second category. That many, I don't know, the third category, and so on and so forth. So the number of stars is going to represent how many objects I'm picking. And how many ones is not N because I have N categories. I need N-1 to separate them. I don't need N. So the number of selection should be the number of ways I can put those stars in the string. So now I'm thinking about this bit string. Bit, it means it has only 2 values on the string. Is it a star or a 1? So now I'm thinking about this bit string and I say, every time I can change the location of my stars, I create a new selection. So the question is, but I have to have 20 stars. I mean, R objects. I have to have R stars. So the number of places is fixed, is R, but I can change where they are. And every time I change my stars, I change my selection. So what's the number of ways this could be done? Who is ready for the formula?
Would it be R plus N-1 choose R?
Absolutely correct. Do you need to memorize it? No, you have to understand it. It's going to be, is it the same thing now? Is it the same thing as choosing N-1 ones? Will this be the same?
Yes.
Because intuitively.
I'm sorry.
Yeah, go ahead. Answer the question.
Well, because I can't really explain it the way I would like to.
Uh-huh.
But it's basically because if you subtract R from the, like how factorials work. I'm sorry.
Right. But,
I had it in my head and I
agree.
lost it.
Yeah, I agree with that. But even if we don't use the formula, the number of ways you can pick those stars is the same number of ways you can pick the ones. Because every time you pick the stars, for every fixed way you count the stars, is the same as the way you count the ones. So if I'm counting the string, I said either you count the string with exactly R stars, which is the same thing as asking you count the string with exactly n minus 1 ones. That's really what's happening here. So algebraically, you can do it using factorial, but the number of string with exactly R is the same as the number of string with the leftover, which is the n minus 1, because this is the R plus the n minus 1. Okay. So let us practice this problem. So the main idea, and you guys have to ask questions, is that in this scenario, that's why it's not called really combination. Sometimes I call it combination with repetition, and that's crucial because the object here, we have our object, they are not distinct. They're absolutely not distinct. Okay, they belong to categories. So one category I have that much, one category I have that much. All right, so let us practice this a little bit, and I'll give you problems along the same lines, and I really would like you to think through the concept. How did I come up with the formula? And start thinking about it. So here, okay, so I'm making you hungry for sweet today. So we have a donut shop. So I'm not changing my scenario. So we have a donut shop. And it sells 7 kinds of donuts. I think I'm spelling donut correctly. Okay, and the question is, in how many ways okay, A, can we select 12 donuts? Okay, so we have 7 kinds. Okay, 7 kinds. And I want to select 12. So the donuts from the same kind are similar. So I'm not really selecting, I didn't even tell you how many donuts the store have. I imagine that the store has infinitely a lot of donuts. So you can pick 12 easily from every single kind. So, okay, we have 7 kinds. In how many ways can we select 12 donuts? So what's the number of objects in this particular scenario? How many objects we have? That's the number of objects we have. How many categories we have? We have 7 categories. So in how many ways? So if you ever forget the formula, which is fine because I personally forget it, I start thinking. So I have 1 category, I have another one. That's really what's happening. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. These are the categories. And here I have 12. So these are my stars. That's how I can pick them. That's how I can pick them. That's my choice. So now I pick 2 from the first, 2 from the second. Let us assume this is again glazed donut, raspberry donut, I don't know, cream donut. I forgot. I don't eat donuts. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And from this category is basically 0. And from this category, I picked 0. That's really the picture. So the number of ways is going to be I have a string here. The length of the string is going to be the 12 object plus the separators between the 7 categories. So that's going to be 12 plus 6.
Professor,
And yes.
I'm curious, do you put a separator at the end of the 7th category or no?
No.
Okay.
No, there is no need for it.
Okay.
Right?
Yeah,
I don't need to separate it from anything else. There is no need. That's why I have 6 of them. Are you with me?
Yes.
Yeah, that's why I have 6 of them. Otherwise, I will have more. And what's the number of object? The number of object is 12. So there are a lot of ways. I mean, it's really, if you start, so it's 18, choose 12. Okay. And so so it's 18 factorial. I don't know if I want to do the math now. I don't think so. 18 minus 12, that's 6 factorial. So if I simplify those, I will have 13. That's what's left, 14, 15, 16, 17, 18. So there are tons of ways, and this is 6 factorial. So there are a lot of ways this could be done. We can compute that number, all right? So the crucial idea here is that if I pick 2 raspberries, those raspberries are the same. So I'm not really having the regular combination we've learned before. Okay, now B. In how many ways can we select 12 donuts with at least 3 raspberries? Okay, I'll give you a little bit to actually think through that. So I want to select 12, but I want at least 3 raspberry. Okay, I like raspberries, so I want 3, and the rest could be anything, including raspberry. How can I think about this question? So just imagine yourself going to the store and you want at least 3 raspberry. What will you do? Yeah, I'm just letting you think through that. I'm giving you time to think through that. And then I will ask what you guys came up with. Anybody ready? Okay, either write on chat what your thinking process, or just let me know. What's your thinking process? How can I make sure I get at least 3 raspberry? Tim, Simon, Rachel, Peter, Nick, anyone? Because I heard Emily. Shy, anybody? Imagine yourself going to the store and you want to pick 12 donut and you want to make sure that it's 3 raspberry. What would you do? Start with 3 raspberry. Okay, that's it, good. And then what do you have to do with the rest? And then random choice for the rest. In how many ways I can do that? I'm still following Pete. So Peter told me start with the raspberry. So if you go to the store and you want at least 3 raspberries, so if I am doing it, I'll go first, I grab 3 raspberry, put it in my bag, and then I start choosing the rest. So in how many ways I can do that? So if I took care of the 3 raspberries, how many I still have to choose? So here on the side, put 3 in the bag if you want. 3 raspberry. Okay, so that's it. And then how many types were there? We had 7 kinds. We have 7 kinds and you want to pick 12. So that's equivalent to select what? Okay, I'll pick. Rachel, what you're thinking? Rachel, are you with me?
Yeah, I am.
Okay, would you think about it? If I want at least 3 raspberry, okay? So I take those 3 raspberry. I already put them in my bag. I'm done with them.
Right. So now you have to fill in the rest of the remaining spaces.
Right.
Not including the category separators, correct?
Which category?
So the categories doesn't matter, which leads me to think that you would just use 7 and multiplying by the remaining spaces. But that would be a different method, correct? That's not what we're trying to solve here.
I'm trying to follow. So how many raspberry do I still have to pick? How many donuts do I still have to pick?
You have to pick 9 more donuts.
Okay, 9. From how many categories? From how many kinds?
Oh, so you would only have 6 categories left.
No. Why not?
No. Oh, because it's at least.
Right. Still from 7 kinds. So it's basically, I'm asking the same type of questions. I'm basically asking the same type of question, but now I want 9 donuts from 7 kinds. And remember, those donuts can be raspberries, of course, because I want at least. So in how many ways can we pick that? All right, and how many ways can we pick that? All right, again, now to go to the star. So now I have 7 categories, so I'm not really changing. 2, 3, 4, 5, 6. So this is 1, 2, 3, 4, 5, 6, and that's my 7 categories. And I want to pick 9 donuts. It means I have 9 stars in here. That's the picture. And there is nothing here, and that's how the picture will pick up. So in how many ways can this be done? So I need to pick 9. And how many, the string that I'm associating to my choice, how many we have. So now the number of objects is 9, and the number of categories is 7. So the choices is, my string now has to have 9 plus the 6 separators. So it's going to have the 9 plus the 6. This is the number of categories minus 1. And this is the number of objects. And the 9 is the number of objects. So it's just going to be equal to, that's how many ways we can do that. Okay? So, all right, so that's really how many we can do. 6 partition being the reason, absolutely correct. We have 6 partitions. So it's not 9 choose 6. It's 15 choose, sorry. Yeah, it's 15 choose 9, or it's 15 choose, my apology, 15 choose 6. One or the other. Okay. All right, I keep along the same now, because the reason, yes, we have to partition, because the object within a category, the objects are the same. Within the same categories, the objects are the same. And this represents the number of objects within each category. Okay, so let's keep along the same lines. So suppose it's the same picture. I'll start a new page, but it's the same problem. So we have 7 kinds. So that's the picture. We have 7 kinds of donut. So this is the number of this is the number of donuts, so you can keep it in track, so a different category. And now my question is, in how many ways we can select 12 donuts with exactly 3 raspberry? With exactly 3 raspberry. Okay. I hope that's becoming slowly, it will become a little bit easier for you to think through it. Again, I'll give you a minute. Draw your stars, draw your separator, and try to think about how am I doing this connection between the stars and the separators. So always words are crucial. Whenever somebody is ready, please speak up. Don't make me choose, because I will. Who's ready? Tim, are you ready? If you can speak. I don't know who can speak, who can't actually. Tim, can you share it with us? Okay, anybody else?
So if it's exactly 3 raspberries, that means that there's no room for, less or equal or more than, correct?
Yeah, only 3. Yeah, so that's it. So keep going, keep going.
So would it still be the 9 donuts that we were working with last time, but only
Yes.
6 categories?
Exactly. Why are you afraid? Yeah, absolutely right. Don't be afraid. So equivalent to choosing 9 donuts from 6 categories. Okay, so I take those 3 raspberry, I'm done with them, I put them in my box, and then I have to pick the rest, which is 9, but I don't have 7 categories anymore because I have exactly 3 raspberries. And now in how many ways this could be done. So as I said, you can start drawing your picture. So we have 6 categories. So I'm gonna separate them. But this time I have 6, so I need 5 separators, the first one, the second, the third, the fourth, the fifth, and the 6th. That's really my categories. And whatever I pick from the first, I associate star to it. The second, star to it. Star to it. So I have 2, 4, 7, and here. That's my choice. So it means from the first, now raspberry is gone. The 6th category, I pick 2 from this one. I pick 2, I pick 3. There's no more raspberry in the picture. 1, and then from one category, let us say I didn't pick anything. And from the last one, I picked 1. That's really my choice. So here the number of objects is 9. And the number of categories is 6. So the number of ways is, you can either use the formula verbatim or you can think about it. So the formula tells me equal is the number, it's R plus N minus 1, where N is the number of categories, R the number of objects. So it means I pick 9 out of 9 plus, now I have 6 plus 5. Means 14, choose 9. Okay. So basically, I usually look at my picture. I have those separators, which are 6 of them, because I have 5 of them, because I have 6 categories. I don't need one at the end. The cutoff is clear by now. And then I put my cookies between those separators. The number of stars I put is the number of cookies I pick from each category. All right, D. Again, select 12 donut. With, let us say, at most 2 raspberry. Whenever you guys are ready, get going. Okay, who has any idea? Nick, would you like to pitch in? It's really up to you. I don't like, the last thing I like is, to make students do something, but would you like to pitch in? Okay, anybody else? How would you do that? Shai, would you like to pitch in? Okay, how are you guys thinking about it? Chris, an idea?
My thought was is that you have to break it down because it's going for at most. So to include 0, 1, and 2.
Okay, we can go along. So no raspberry. plus exactly 1 plus exactly 2. Okay, that's how we have to do it. Very good. Now, for each situation, what is going to be the answer? If we have no raspberry, it means the number of objects, we're still picking 12. And how many categories we have here? Quickly, Chris.
7.
Are you sure? Why 7?
No. 6. 6.
6. Absolutely. So now we imagine we're going to pick 12. So we have 12 stars because that's a 12 object. But now we have 6 categories. So it means the string will have links 12 plus the 5, which is coming from here. And then I move. 1 raspberry, exactly. Now I have less object. 11. And I have only 6 categories because I only want 1. So now I'm going to pick not 12, I'm going to pick 11 object, 11. But then, so this is the stars, and how many ones I have is the number of separator, which is 1 less than the number of categories. Exactly 2. Now I have object. I have 10 of them. And the categories, I have again 6. So now I'm going to have 10 star on my string. And I will have the 10 star and I will have the ones, which is what separate my categories, which is 5. And then we just compute this number, and I advise you to compute it, and you realize it's actually, it's a huge number. But there are so many ways we can pick those 12 donuts with at most 2 raspberries, a lot. Please ask questions. I'm of course gonna assign homework, practice problem a little bit so you guys can interact, but you have to think through it. You have to think a little bit through it. Any questions before I move on? No.
Oh, so
Yes.
for that, you're just adding like each and every one of them?
You have to.
Okay.
Absolutely. Absolutely. And you can use your calculator to add, to compute the combination. You guys know that. Figure it out on your calculator, you can compute them because it's not always easy. Plus 17, choose 11, plus 15, sorry, what am I doing wrong? 17, and this is 16, and this is 15, choose 10. Okay, and you can evaluate this. I didn't. We can try to evaluate this, and we actually get a really lot of. We have tons of choices, a lot of choices. Now I will set up the last problem in front of you. We will think about it a little bit, and I'll let you think a little bit more about it at home, so you guys can interact with that. So my last problem is the following. Okay. How many, and it's going to fit into the same picture, but it doesn't look like it's going to fit, but this actually will fit. So one more example is the following. How many solutions are there to the equation? X1 plus X2 plus X3 plus X4 equal to 10, where the solution I'm interested in are not just any solution, where every X is an integer. Sorry, not an integer, a natural number. And let me remind you, the natural number in this class are 0, 1, 2, 3, etc. Okay, so I want all the solution, which are basically integers, either 0 or positive integers. So let us see, first understand. So what do I mean by solution? So for example, I can pick, let us select a solution. 2, 2, 8, 2. So that's a solution. 2 plus 2, 4 plus 4, 8 plus 2, that's give me a 10. So there are a lot of them. I mean, you know, you can pick 0, 0, 0, 10. That's a solution. So you can imagine that there are a lot. My question is, how many? With me? Okay, we're going to think a little bit along the same line, but how can I think along the same line? So I'm going to take this solution, 2, 2, 4, 2. And I'm going to ask you to kind of assign to it some kind of a string that can represent the solution. What would be your string like? Because we're going to think exactly along the same lines for this problem. Okay. Now, what kind of string you think I'm going to associate so that the number of strings I have with a certain property correspond to the number of solutions? What should be the string?
It'd be like 2 stars, a separator.
Okay, tell me what we want me to put here.
The line, so like 2 lines in a separator, or so. We want to break it down like in the numbers wise.
Mm-hmm. I want a string of stars and bar and ones, so that if I give you the string, you know the solution. And if I give you the solution, you can describe the string for me. How it's gonna be. Anybody, just come up with any ideas. So I want a string here that it tells me, basically, if I see it, I know the solution, and vice versa. So I'm building this relation, this correspondence between solution and string, because those are hard to compute. I want to compute something easier. So what would be your choice?
Would an option be to have 10 stars and then the categories divide those up?
Okay, tell me what you have in mind. Tell me what to draw.
So I would just have 10 stars.
3, 4, 5, 6, 7, 8, 9, 10. Very good. But
And you're going to have 3 separators.
where? Tell me where.
In this specific one, you would have one after the first 2 stars,
Uh-huh.
and after those 2, then after 4. And then those would be each representing an X.
Exactly. That's the idea. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, let's do that. What would be your choice? So that's really how we're going to do the correspondence. So we have to see that computing the solution is like computing those strings. It's exactly the same. So so she put the tens. These are her 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But now we have to go. So that's the 1, 1, 2, 3, 1, 2, 3, 4. That's what it is. So here we're putting basically 2 stars, which represent the value of x1. Here, basically, we're putting the value that correspond to x2. So instead of putting 2 stars, I'm going to change. I'm going to put here x1 stars. That's the value of x1. And this is x2 stars. And here, x3 stars, and here, the x4 stars. So that's really my category. So that's how I'm dividing my categories. So the first category is the number of whatever the value of x1 is. I put as many stars as the value of x1. The second category, as many stars as the value of x2, and so on and so forth. So now every time I give you any string, you should tell me. So the idea is that we have to make total correspondence. So I give you the string. So I'm just going to make up stuff. 2, 3, 4, 5, 6, 7, 8, 9, 10. And I'm going to separate them this way, this way, this way. So what is it? So this is my string now is 1, 2, 3, 4, 5, the 1, 2, 3, 4, 5, 6. Okay, this is my string. So what solution I am associating to that? What solution? That's the correspondence between them. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Nothing. Nothing. That's the solution I'm associating to that. So that's really how we're talking. Instead of counting those now, I'm counting that. So how do I count those? So basically now I have this bit string. And the way I compute them is the number of ways I can position my stars. Every time I'm changing my stars on this string, I'm getting a totally different solution. So here we can think of this problem as where the number of objects is 10, equal to 10, and the number of categories is equal to 4. That's how we can think about it. And as I said, the good thing to think about those problems is actually start drawing a little bit so you know exactly what is really going on. We have to see this correspondence to be able to figure out exactly what the picture looks like. So the number of ways is going to be, we're picking 10 objects. That's a string, and it has to have the 10 object plus it has to have the 3, which is basically the n minus 1, which is, if we compute that, we get 10 here and we get a 13. And now the question is how much? Actually, I did the math here and I got 286 solutions. So this equation, this simple equation, I'm asking only for the integer solution. So this equation, the number of integer solution is actually going to be 286 solution, which is absolutely impossible impossible for us to count them. That's why we need like a way to actually think about it. And this is how we are thinking about this problem. Okay. Now I can start having variation on this. So I can like insist that x1 should be greater than 1. And then I can ask you, okay, and how many ways this could be? And then we think a little bit. If I want like x1 to be greater than 1, okay, what will happen in the rest of the picture? I think this will come up as your practice problem. All right. At this note, you guys will have practice. I am finishing combinatorics. So you will get a homework. I'll be working on it. So hopefully by Friday you will have it and you'll have enough time to do it. And next week we're gonna go back to logic and proofs and stuff like that. Okay, any questions? I have to leave early today because my linear algebra have an exam and I want to get them started. Do you have any questions before I let go? Okay, have a good weekend and I'll see you next week. Bye-bye for now.